Welcome back. This tutorial is a continuation of the last tutorial. So we're still on lesson 5, enemies. And in the last tutorial, we made it so that we were spawning snowmen on our level, but currently the snowmen don't move. So in this tutorial, we're going to make it so the snowmen actually turn and face the player and move towards me. Now you can see at the moment, there is a collision there. I can't go through them. But when we do make the snowmen move, until we deal with collisions properly, you will find that the collisions are going to start bugging out. Right, so to do that, we're going to go to snowman, and we're going to use the update function inside snowman, because remember that Ursina will call the update and input function of any entity every frame. And so we want to make it so the snowman every frame looks to see where the player is and moves towards the player. Now, we have got player currently stored inside global variables. So we can actually, firstly, we want to test to see if the player exists. And I'm going to do that because if during the game the player dies, you don't want the snowman looking for something that no longer exists. You'll get a nasty error. So I'm going to say if globals.player, that is the player exists, and if the player is enabled, during the pause mode of the game, the player is actually disabled. So if we're paused, we don't want the snowman to continually move towards the player. The next step is we're going to look at where the player is. And Ursina has a really cool function called lookat2d. So every entity has this function. By calling the function lookat2d from the entity class, it's going to look to see where position is on our screen in 3D space. So the position would be an X, Y, Z position in 3D space. I'm going to feed it the player's position, and I'm going to make it so that it looks by rotating on the Y-axis. So the Y-axis is going up and down. You can imagine that rotating on the Y-axis is going to affect the direction in which it's facing. And then once I've done that, I'm going to get it so it moves in that direction. So when, and this is an interesting point, when an entity is rotated, it has a forward vector, and that forward vector is changed. And the forward vector is simply the X, Y, and Z units that would be changed as your entity moves in that direction. So it's an X, Y, Z component, and we're going to keep adding that X, Y, and Z component to the player's position, and that's going to create movement. So self.forward is a vector in exactly the same direction as our current rotation. We're going to change that, times that vector by the change in time, because obviously we don't want it to go too quick. And the frame rate will determine the time. And we're going to times it by the speed of the snowman. So that there is going to keep updating the position of our snowman on the screen. So let's see how it goes at the moment. I'm just going to press play. And what we should find is that with the snowman, it rotates towards us, no matter where we are in the world. As the snowman appears, so I'm moving around the snowman, and the snowman's rotating to face me each time, and it's going to continually moving. Now, I did tell you that the collisions would bug out at this point, because even though the snowman collides with me, every frame it's being told to keep moving. So it's going to keep moving regardless of the collision itself. And sometimes I can jump on top of the snowman, but the collisions no longer work properly. They're there, but the snowman is being told to move on regardless. We will be fixing up the collisions at a later point. Okay, now at this point here, we've got a choice when it comes to gameplay. And look, the gameplay is up to you anyway. You might decide the snowmen are moving too slow, in which case you would update the speed. But you also might like to make it so the snowman only moves towards the player if it's within a certain distance. To do that, we can use a distance function. Ursina has a number of distance functions available for you. There's distance xz, which is the distance along the xz plane, or there's distance xy, or there's distance zy. You get the idea. The distance simply returns a value based on the two positional vectors. So I'm going to feed it the player's position, I'm going to feed it my own position, and it's going to work out the distance between us along the xz plane. And then I'm going to decide, okay, well, if the distance is less than 50, but greater than 2, then I'm going to move towards the player. And this is just a really simple way to make sure, that the player, the snowman doesn't go too fast, if that makes sense, or move towards me too much. So that's a really simple way of doing it. If I press play now, you notice that the distance is now restricted. A lot of the snowmen on the world aren't even going to move towards me, which may or may not be what you want. The more complicated way of doing things is using raycasting. And I'll give you an example of that as well, despite the fact it's probably not really necessary, and it really depends on the game that you're doing. But I'm going to move away from this snowman until I'm like 50 away. Oh, actually I didn't mean to run off the field. This is why you need a wall around your world. But it will stop the snowman from moving towards me. Okay. Raycasting is another way of doing the same thing. It's probably a bit more computationally expensive. But I will show you raycasting because I think it's good preparation for when we look at collisions. So to put simply, raycasting is where you cast a ray from your enemy or an object, an entity, towards another entity or another position. And if it hits that position, it's going to be able to do something. So the benefit of raycasting is that if the ray is actually interrupted by other entities, it will actually return false. So what that means is you can make it so the enemy is actually only going to move towards the player if it can see the player. So if I run behind the house, the snowmen on the other side of the house aren't going to move towards me. Now again, it really depends on your gameplay. So to do raycasting, you create the ray, you choose the position that the ray is cast from. Note that I actually added a Y unit to my position. The reason being is that each snowman's position currently is based on the ground. I made it so that its origin is on the ground. So if you have a look, you can't see it there, but its actual origin is actually on the ground itself. So because of that, I've made it so that the ray is actually coming from the middle of the snowman, which is that there. It's going to go in its forward direction. The ray is going to travel a distance of 100, and then I can choose what entities I want it to ignore. So I've put in the fact it's going to ignore itself, and then I also put in every other enemy that is around. Now, that there might be a bit complicated code for most people. I'm not sure. Look it up on ChatGPT if you want to get an idea of what it does. But it's going to take every other enemy in the world, and when it casts its ray, it's going to ignore that. So it's going to be, even if there's an enemy in the road, it's going to ignore those enemies. Now, if I want to actually see the rays, I can actually put debug is equal to true, and I'll do that. And then I say if the ray had a hit, I can check what entity it hit. So I'm going to check that it hit the actual player itself, and then I can update the position. So this is just a really cool way of making it so the enemy only moves towards the player if it can see the player. Right, so we're ready to press play. As I said, I've put raycasting on debug mode, so we should be able to see some of the rays, hopefully. And there's a distance of 100 there as well. So it kind of does the same thing as our distance function. You can see the rays. See the rays are traveling. You can see the lines of the snowman. If I hide behind the hut, you can see that there's a snowman behind it that isn't moving. But as soon as the snowman can see me, they start to move. This is computationally expensive though. Raycasting is going to take a bit of maths, so it's actually going to slow down my processor. But you get an idea about how it works. Personally, for my game, I actually want the snowman to keep moving towards me regardless of where they are. I just wanted to show you those functions in case you wanted to have your game that way. All right, that concludes our tutorial. Thank you very much for listening.